Hello students. Welcome to Geeks Knowledge. Imagine you need to measure the height of a tall redwood tree, or a skyscraper, but you can't climb to the top. How do you measure something impossibly tall, without ever leaving the ground? A tree standing straight creates a vertical height, while its shadow stretches along the ground. The ray of light connecting the top of the tree to the tip of the shadow completes a right triangle. Long before global positioning system, sailors navigating in the dark and dangerous coastlines faced a critical question. How close are we to the rocks? And, without ever touching the shore, how could a navigator calculate their exact distance to a lighthouse, using only its height and the beam of light? Here, we can see the exact same right triangle formed between a lighthouse and a sailboat on the water. We can label these sides A, B, and C. In both the cases, we uncover the exact same shape, a right-angled triangle. And this brings us to one of the most powerful and widely used rule in mathematics, the Pythagorean Theorem. That is, a squared plus b squared equals c squared. Welcome to this visual proof of the Pythagorean theorem, presented by Geeks Knowledge. Consider a right-angled triangle where side A is perpendicular, side B is base, and side C is hypotenuse. By definition, in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Building a square on side A gives area equals a squared. Building a square on side B gives area equals b squared. Combining these two areas forms the hypotenuse square with area equals c squared. Thus, we get the algebraic relationship, that is, c squared is equal to a squared plus b squared. Now let us apply real numerical values to see this theorem in action. Suppose perpendicular or equals 3, base b equals 4, and hypotenuse c equals 5. The area of side A square is 3 squared, which is 9. The area of side b square is 4 squared, which is 16. And the area of hypotenuse square is 5 squared, which is 25. Substituting these values into our formula gives 9 plus 16, which perfectly equals 25. This confirms that the Pythagorean theorem holds true for all right-angled triangles.
In this right-angled triangle, side A is 3 and side B is 4. The hypotenuse C is unknown. To find the hypotenuse, we start with the Pythagorean theorem. A squared plus b squared equals c squared. Substitute the known leg lengths into the equation, 3 for A and 4 for B. Squaring 3 gives 9 and squaring 4 gives 16. Their sum is 25. Taking the square root of 25 gives us 5. So, the unknown hypotenuse is 5. Likewise, if you need to find any other side instead of the hypotenuse, simply rearrange the same formula. For instance, a square equals c square minus b square. Or we can also say, b square equals c square minus a square. The Pythagorean theorem states that for any right-angled triangle, the sum of the squared legs equals the square of the hypotenuse. No matter how you rotate, scale, or orient the triangle, this fundamental geometric relationship never changes. When we bring this exact relationship onto a coordinate plane, it unlocks a straightforward way to calculate the distance between any two points. In the next video, we will derive the distance formula step by step.